So the first page, these are all right angle vectors, which is kind of nice because when you add them, you don't really have to change them back to coordinates. And by the time we get to the last page, we'll be changing all of those to coordinates to be able to add them. So here's the first example. A man walks east 45 meters. So here's him walking east 45 meters. And then he turns south 23 meters. Now at first I'm going to write it at the origin just to show you something. I could write it at the end of the 45, which is probably I would do if I was doing this problem on my own. I just want to show you something. So south 23. Now what I want to show you is if I write the vectors like that, adding them doesn't really make sense. So if I move that 23 to the end of the 45, what I end up getting is a very nice resultant vector, which forms a right triangle. So for this one, it's nice because to find the magnitude, it's just the Pythagorean theorem of the two vectors, and the angle is just going to be the inverse tangent of the 23 over 45. So the magnitude is the square root of 23 squared plus 45 squared, and the angle is going to be the inverse tangent of y, which is 23, over x, which is 45. Okay. So I'll do both of these in the calculator. For some of them, I won't do that since I don't want to waste too much of your time when you watch this. But so first one, second square root 23 squared plus 45 squared. So my magnitude is 50.54. And the second one, I want to do the inverse tangent of 23 divided by 45, which turns out to be 27.07 degrees. Now, when I give my final answer, I want to make sure I pay attention to the units, and I also want to make sure I pay attention to what direction this thing is going. So it is 50.54, and we're talking meters, at a direction that's 27.07 degrees. It's a little south of east. And so that's my final answer. Okay, so the rest of the ones on this page are similar. If you have any questions about them, please let me know and I can work out some other examples. I want to get to this second page. Okay, so for this one we're going to do one more thing. Not only do I want to do the resultant vector, and I want to do the direction and the magnitude. Okay, so I can figure out the x, y coordinates for each one of these. I can add them together, but then I'm going to have to change it back to a direction and a magnitude. Now the top three are nice because they're already lined up tip to toe. So for the first one, the resulting vector is from the beginning of the first one to the top of the last one. So the resulting vector for this one would be over 1, 2, 3, 4, and up 1, 2, 3. Now, notice if I add the vectors together just using the coordinates, I'll get the same thing. So the first vector is over 4 and up nothing. And the second vector is over 0 and up 3. So when I add them together, I end up getting 4, 3 anyway. So notice there's no difference between my answer. And especially for the later ones where they're not set up tip to toe, you might just want to change them all to XY notation and add them that way. Okay, so now to find the direction and the magnitude. First thing I got to do is the magnitude's the Pythagorean theorem, or this is a 3, 4, 5 right triangle. So the magnitude is going to be 5. Now I also want to find this angle. Now when you find all of these angles, go to the beginning of your resultant vector and draw a horizontal line. These are not north, south, east, west. So here's how we're going to do our angles. If you draw a horizontal line at the beginning of your vector, that's going to be 0 degrees. And what you're trying to find is how far from 0 degrees you are. So for some of these, you're actually going to go past 90. You might even get around past 270 in some places like that. So you're always going to count that vector. Okay, so to find this, I'm going to use tangent. So it's going to be the inverse tangent of y over x. So 3 over 4. So if I take my calculator, second tangent, 3 divided by 4, and I get 36.87. So this angle is 36.87 degrees. And I'm done with that one. Okay. I want to do one of the other ones where they're not tip to toe, just to show you how those work. So again, at the top, here are the two main things you need to know. The magnitude is always equal to the square root of x squared plus y squared, and the angle is always equal to the inverse tangent of y over x. Okay. So let's do 9 because it's such a neat one. Okay, now if you notice 9 actually is lined up toe to tip, toe to tip, toe to tip. So all the vectors go around. So the resulting vector for this one is actually just from the beginning of the first one to the end of the last one. So if I change this to coordinates, it's over 2, left 2, and up 1, 2, 3. And again, if I don't want to do that, I can change all the vectors. So in this case, 1, 2, 3, 4 of them into vector notation and add them. So just to show you it works. The first one 0, 4. The second one is 2, 0. The third one is left 1, down 1. So negative 1, negative 2. And the last one is left 1, 2, 3, up 1. And if I add those all together, and I didn't make any mistakes, I should get negative 2, yay, and also 2 plus 1 is 3. So notice I get the same answer. Okay. Now, so the magnitude for that red vector, the resulting vector, is going to be the Pythagorean theorem. So it's going to be the square root of 2 squared plus 3 squared, and you can put that in your calculator. And the angle is going to be the inverse tangent of the y value over the x value. Okay. Now, one thing I would do is I want to check that one because sometimes there's always two angles that'll have the same tangent. So let me draw what I think would be the angle. So here would be my 0 degree line, and I'm trying to find this angle right here. And obviously it's going to be a little more than 90 and a little less than 180. So I'm not going to do the magnitude, but I do want to do the tangent just to check something. So the inverse tangent of 3 divided by negative 2. Oh, I'm sorry, I didn't hit inverse tangent. Inverse tangent of 3 divided by negative 2. Okay, so I get negative 56.31 degrees. Angle is about negative 56.31 degrees. Now, here's one little thing that you might have to fix on some of these. Not often, but sometimes you have to do that. If I draw this angle, it's actually in the down direction. It's actually going to be over here, going in the totally opposite direction than my vector. So this actually is the negative 56.31 degrees, which is 180 degrees off from what I want. So if you ever notice that happens, and you can eyeball it, it's not going to be like it's really close. It's going to be 180 degrees off with what you're expecting. All you have to do is take your answer and add 180 to it. And my actual answer is 123.7, and that's a lot more what I was expecting. So my actual answer is 123.69. And let me show you why that happens. It happens because there's actually two angles that have the same tangent in 360 degrees. If I do the tangent of 10, I'll get the same answer as if I add 180 and I do the tangent of 190. Well, when I ask my calculator to do the opposite of that, and I ask, well, what angle produces this tangent, it's only going to give me one of those. So if I get the wrong one, I just add 180 to it, and that will be the right one. So for some of these, if it seems 180 degrees off, add 180, and that'll be your angle. Okay, so I want to move on, and I want to do some from the third page.